Hey everybody, and welcome to our first video. Here I am out in the middle of the woods. It's the best place to do math. So in this first video, we're going to actually talk a little bit about algebra. So before we start our calculus curriculum, I need to make sure that you understand some of the basics. So we're going to talk a little bit about exponents and radicals. We're going to expand some polynomials. We're going to factor some polynomials, solve some polynomial equations, work with some rational expressions, and finish off with some linear equations. I'll see you on the next slide. So first up, we're going to talk about exponents. Now, there are some basic properties of exponents that I need you guys to be comfortable with, and they are outlined right here in this definition. So make sure you look these over. I want to put it all in one location so that you can refer back to these properties. And then we also have three very important properties that we're going to be talking about. So multiplying two expressions that have an exponent, dividing two expressions, or raising an expression to an exponent. So make sure that you're familiar, and you can pause this video and check out those quick examples. Now, with these properties, we're going to actually simplify some expressions involving variables. So I'm going to zoom out here. Let's take this up into the corner. So we're going to be referencing these properties, and we're going to look at a quick example. So it's going to have two parts. Let's look first at part A. I want to simplify the expression 5x to the third all raised to the squared power. Now the important thing is that this square is going to apply to the 5. So it's going to apply first to the 5, and then it's also going to apply to the x to the minus 3. So we can rewrite this now as 5 squared times x to the minus 3 squared. And keep, look at how I use these parentheses because that's very important. Now what we can do is use one of our exponent rules that says that if we have x raised to some power and we raise it to another power, you're going to multiply those powers to get x to the minus 6. And we do not like negative exponents, so we are allowed to actually rewrite this with the negative exponent in the denominator where we can write it as positive. So our final answer, our simplified expression, would be 25 over x to the 6th. All right, let's apply a similar technique here. If I want to simplify this, first on the inside, I know that a square root is really raising something to the 1/2 power. And now since I have an exponent raised to another exponent, the rule tells us that we can multiply those two exponents together, so we'll get a negative 1/2 exponent. And essentially all that's doing is, now we're going to put that in the basement, or in the denominator here, and we can go back to radicals if we like, or we can leave it in this exponent form. Okay. Another way, you could just you could look at it from the beginning here, and you could just say to yourself, oh, okay, that's a -1 is really just flipping this over. So we're actually taking the reciprocal of that initial expression, and this would be an appropriate answer as well. Okay, so work with some of these things. It all comes back to the rules. I don't want to spend a ton of time in this video. I do want you to guys to get your hands dirty with it. I know you've seen this before. All right, I'll see you on the next slide. All right, our second topic is expanding expressions. Now there's basically two rules you need to know here, and these can be expanded to other rules as well. But if you have A multiplied by the quantity B plus C, the distributive property tells us that we need to take that A and we need to distribute it to both the B and the C, preserving whatever the plus or minus was on the inside. So you end up with A times B plus A times C. That's the distributive property. Now, if we have two terms, these are called binomials because there's two terms involved in each, so two binomials, you have to take the A and distribute it to the C and the D, so you'll get AC plus AD. And then you have to take the B and do the same thing, distribute it to the C and to the D. So you'll have BC plus BD. Okay, that's the main rules. Of course, if you have 3 terms multiplied into 4 terms, you can do the same thing. But every term from the first expression has to be distributed to every term from the second. Color coding it really, really helps. Let's do an example. So let's expand the following. Part A, x plus 2 times x minus 4. So again, I'm going to color code it. You take the x, you distribute it to the x and to the 4. So you'll end up with x squared minus 4x. Again, that sign is preserved with the 4. It's a minus 4. Then go to the 2. You'll have a positive 2. That sign is preserved with the 2. Multiply it by the x and by the minus 4. So you'll end up with plus 2x minus 8. Okay, we'll combine like terms. We end up with x squared minus 2x minus 8. And that would be the expansion of this of this binomial. In the second one here, we actually have two steps we have to do. So first I'm going to take the x and distribute it into this first term. And we'll end up with 4x squared plus 7x. So that's the first step. Now I can do the step that we just talked about. Take the 4x squared, we go to the 3x and the minus 7. So we end up with 12. You multiply the coefficients. X to the third, that's our power rule involving the exponents. X squared times x, you add the exponents. And then I have minus 28 x squared. And we'll go to the blue now. 7x times 3x is 21x squared minus 49x. And of course, you can then combine like terms. So you have 12x cubed minus 7x squared minus 49x. So that's pretty straightforward. Basically, to get from this top step, to get from here down to there, we use the distributive property. To get from here down to there, we use the distributive property. On the next slide, we're going to talk about factoring, and that's when we start here and work back up the ladder to get to the factored form. Work here and work back up the ladder to get to the factored form. So factoring is the complete opposite of expanding, and it can be a little more challenging. So on the last slide, we talked about how x plus 2 times x minus 4 is equal to x squared minus 2x minus 8. We're now going to start here, and we're going to learn how to factor and get back to this. Now, let me preface this slide by saying there are so many different ways to do this. So if you've learned it in the past and you know how to do it, some people can just look at it and do it. That's great. That's fine. If you want to learn a method that will work every time, I'm going to outline such a method. So if you've already done this, you know how to factor, you can go ahead and skip ahead. So let's discuss the method to factor expressions of the form ax squared plus bx plus c. These are called quadratics because the highest power is a square, and they're called trinomials because there are 3 terms. Okay, so how do we do this? I'm going to illustrate it with a few examples. You're going to see the procedure, and you'll understand the technique. All right, so let's start with our first example. X squared minus 2x. Oh, I want that to be a minus. We'll do it as a minus 8 because I want it to be that example that we started with on the top right of our screen. So to do this, to factor this, we need to find 2 numbers, 2 very special numbers, and those 2 numbers are going to go, are going to go into these boxes. So I'm going to put 2 little boxes here. What do these 2 numbers need to satisfy? These 2 guys need to have a product of a times c. So whatever the a and the c is from the original form, so in our case we have a 1 and a minus 8, so I need a product of minus 8, and I need a sum of b. So b is that middle number in our case, which is minus 2. So you're looking for 2 numbers with a product of negative 8 and a sum of minus 2. And you can probably just think about this for a little while, and you'll end up with minus 4 and 2. If you can't come up with those numbers right away, make a list on the side. You can actually sketch out a list of all the factors of minus 8, and you'll be able to find the one that has a sum of minus 2. So those are the special numbers. Now, what do we do with those? Okay, you're going to rewrite the middle term using those 2 special numbers. So I'm going to leave the x squared alone, and instead of minus 2x, I'm going to write minus 4x plus 2x. So notice I used my minus 4 and my 2, and I've rewritten minus 2x in this new form. It's the same thing, so I haven't changed anything, but I've rewritten it. Okay? Now, the very next step is to factor this. There's 4 terms. Factor it by grouping. So you're going to group the first 2 terms, and you're going to group the last 2 terms. It doesn't matter which order you do this. So if you had written 2x minus 4x, you're still going to get the same answer. So we have x squared minus 4x. You take out a common factor from that green group. It's an x. Okay? Now take out a common factor from the red group, and it's a 2. So you take out a plus 2. And what's left is x minus 4. So you factor the green, and you factor the red. Now we factor this entire thing because I noticed that they both have an x minus 4, so we can pull that out. What's left from the green group when I pull out an x minus 4 is an x, and what's left from the red group is a plus 2. And there's your final answer. You have x minus 4, x plus 2, which is exactly what we were looking to get. Okay, but this is the technique. So you might be saying, Dave, you're making this way more complicated than it needs to be. I get that, guys. If you know how to factor, you know how to factor, and you can see it right away. But this technique works for other quadratics that might not have a 1 at the beginning. Okay, I know all of you can do that with a 1. Let's look at ones that don't have a 1. So here we look at part B, 2x squared plus 9x plus 4. Here we go. Some of you can kind of guess and check your way through this, but let's actually use this same exact technique. So again, I'm looking for two numbers, and I put these two boxes just for the effect. I want two numbers that have a product, in our case, of A times C. Well, A is 2, C is 4, so I need a product of 8. And I need a sum of B, and B is 9. Okay, so you want a product of 8 and a sum of 9. So you think through this and you can kind of come up with all the combinations. Of course, you're going to end up coming to the conclusion that 1 and 8 are your special numbers. Okay, so what you'll do is you're going to rewrite that middle term. So again, you rewrite the 9x as plus 8x. I don't want to use blue there. Plus 8x plus x plus 4. Again, if you wrote plus x plus 8x, that'd be fine in the other order. No worries whatsoever. So all of this is kind of sidebar. That's secondary to the problem. Same with this. That's always just a secondary part of that problem. Okay, so we've rewritten it. Now let's do it by grouping. So we group these first two. We group the last two. All right, so we group this first two. We end up taking out a 2x. We're going to end up with x plus 4 left. We're looking to take out the greatest common factor. For the red, the greatest common factor is a 1. Okay, and then you take out the x plus 4, and you're left with 2x from the green group and 1 from the red group, and there's your factored version of this. Okay, now you can always go back, expand it out, make sure you get the right answer. So I think I do want to do one more. So again, you can skip ahead if you get everything that that we've done so far. But let's shoot for one more, and that'll be part C. So let's look at 2x squared minus 7x minus 15. So again, I want two numbers, right? I want my two numbers. In this case, I need a product of A times C, which is negative 30. And I need a sum. My two numbers have to sum to B, which is negative 7. Okay? Now again, you can list out all of the numbers that give you a product of minus 30 and then find the one that gets you a sum of minus 7, or just think about it. You'll get negative 10 and 3. Okay? So you rewrite that middle one, the minus 7x, you'll rewrite it as minus 10x plus 3x minus 15, and then we go by grouping. So we're going to group. We group. We'll take out from the green, we're going to take out a 2x. What's left is x minus 5. From the red, we're going to take out a 3. What's left is x minus 5. Look at that. They both have an x minus 5. That is by design. That's because we know what's going on here, and that's the part of the procedure. We're going to be left from the green group with a 2x and from the red group with a 3. And there's your factored version of what we get. Alrighty? So part 3 of our algebra review is going to involve solving equations. This is also known as finding roots of polynomials. So suppose that I asked you to solve, I didn't write it here, but suppose I asked you to solve this equation. So I have some polynomial on the left, it's a cubic, equal to 0. What's really happening here is you have this function, think of this as f of x, right? And f of x has some particular graph, and we're looking for when that graph crosses the x-axis, so when the graph has a y value of 0, and that's why we talk about finding roots, okay? But in any case, let's see algebraically how we should go about doing this. So let me get this erased here. What you're first going to want to do, step 1, would be to factor this expression on the left. So make sure everything's on the left and then factor it. So I'm going to take out a greatest common factor of an x first. And then I'm going to continue to try to factor this. So referencing the last slide, you can see what this would factor to. And what you end up with is x minus 8 times x minus 9. Okay, again, you can check that on your own. So this equals 0. What now happens is we use what's called the zero product property. So I have three things that are multiplied together that equal 0. We know that if any one of them is 0, then you satisfy the equation. So we actually get 3 roots. X equals 0 would make the whole product 0. X equals 8 would make the whole product 0. And x equals 9 would make the whole product 0. So you take each of those individual pieces and you determine what x value would make it 0. And, I'm kind of skipping the step. In this case, you're setting x minus 8 to 0, and that's where you get the x equals 8, and same for the x minus 9 side of things. So we end up with 3 roots, and those 3 roots are x equals 0, x equals 8, and x equals 9, and that would be the answer to this question. So if that were part A, let's do part B over here. It looks really harmless. So right away you might say, uh-oh, we don't have a 0 on the right side. Well, we can get one pretty easily by just swinging that 2 to the left side. And then we can factor, again, using the techniques that we talked about in the last slide, we can factor this. So we'll end up with x plus 2, x minus 1. Okay. What I want to really encourage you guys to do throughout this course, anytime you factor, always check it. Expand it back out and make sure that you did it correctly. Okay, and now we use the zero product property, so I know I can either have x plus 2 equal to 0 or x minus 1 equal to 0, which gets me my 2 roots of minus 2 and 1. Okay. If you were to take these and input them back into the original equation, you should get something that satisfies, that satisfies that equation. Part 4 of our algebra review involves rational expressions. There's a big misconception on what a rational expression really is. It's very simply just a fraction that involves 2 polynomials. So it's an expression that has a polynomial divided by a polynomial. Naturally, since 1 is a polynomial, really any polynomial that you have, say x squared plus 2x, that's a rational expression because you could express it as x squared plus 2x over 1. So it's a very general definition, and a lot of people confuse it. But in any case, we just need to know how to work with these things. So what are we going to be doing? We're going to be simplifying rational expressions. Let's do a few examples. So let's look at these 3 examples where I just want you to simplify. Basically, that means combine it and reduce to a lowest form. Now, as with anything in math, there's a ton of different techniques for doing this. So if you know how to do this and you don't want to hear my approach, that's great. I'm not trying to change the way that you do it. But this is the way that I approach these things. So let's look at part A. If I want to combine these 2 fractions, this is a method that I actually remember vividly learning from my mother. And it's just combining 2 fractions. These are really just 2 fractions. What you're going to do is you're going to start with the 1. You multiply by the denominator down here, so we end up with x minus 2, okay? You preserve whatever the sign was, so the sign here was a plus, so I'm going to have plus. I'm going to put some parentheses here. Then you take the x plus 2, and you're going to multiply up here by the 1, so you end up with x plus 2, okay? And we divide this whole thing by the product of the 2 denominators. So you'll have x plus 2 times x minus 2. That technique will always work to combine 2 fractions. It might make it a little more difficult than it needs to be, but it will always work. So anyways, on top we'll combine like terms. Everything's added, the parentheses can be dropped. So we end up with 2x minus 2 plus 2, those are going to cancel. And then on the denominator you'll have x plus 2, x minus 2. And that's it. That's a nice reduced form of this rational expression. All right, that's rational because I have a polynomial over a polynomial. So let's do the same thing on this side. So again, you start with the x squared, you multiply by the x minus 5. So that's going to be distributed into that. So you'll have x squared, x cubed. Let me get rid of that squared. X cubed minus 5x squared. I'm going to put that in parentheses. Then you preserve the sign, so that'll be a minus. Then you take x plus 3 and multiply it into x plus 1. So I am going to not do that yet, so I'll keep it there. And you divide by the product of the denominators, x plus 3 and x minus 5. Okay, and now your job is basically to expand everything, combine like terms, etc. One big thing here is make sure you put some brackets here, because that minus sign is going to apply to everything in green. after you distribute it all. So you'll have x cubed minus 5x squared minus, and we have our bracket. I'll keep it with a square bracket. And now expand the green. So you'll have x squared plus 4x plus 3 with our expansions. In the denominator, I'm going to leave it as a factored form. There's no reason to expand it because there's nothing to combine it with. Now up top, that minus sign is going to apply to every term in those brackets. So don't forget those brackets. And as we do that, you'll have minus x squared minus 4x minus 3. We're going to combine like terms in a second. And you'll have the denominator still being the same way. So you combine your like terms, it basically just combines those squared pieces. That'll be your numerator, and this will be your denominator. So you might say, well, Dave, should we try to now factor the numerator again? Don't worry about it, guys. Basically, when we're simplifying these things, we want to combine like terms and reduce it as much as possible. It's a method. It's an idea. Basically, some people like to see it factored or unfactored, so don't worry so much about that. Now, part C. This technique will make part C a little bit more challenging, and I want to look at that specifically, so I'm going to give you a new technique for part C. When I scan part C, I noticed something different about it, and that's that the two fractions I'm trying to combine, they actually have a like term. Okay, they both have an x. So if I did do this process, it will work, but it will make it a little bit more complicated than it needs to be. So another approach, I'm going to give you another approach here, is to combine them using common denominators. So both of them have an x, and the one on the right doesn't have any other factors in the denominator. So what we can do is give it the factor that we need it to have a common denominator with the first expression. But the price I have to pay if I put it in the denominator there is that I have to multiply it into the numerator as well, right? So that's effectively doing nothing because I'm multiplying by 1 essentially, the blue on top and blue on bottom. Now they have the same denominator, and you can put them over the same fraction. So that's the idea of having common denominators, just the same as numbers. And on top you'll have 4 minus x plus 1, x plus 2. Okay, again, put your bracket so that you don't forget that minus sign applies to both. I'm going to pause the video and finish this example. So we end up with the final answer here of minus x squared minus 3x plus 2 over x times x plus 2. Notice that we like to write things in decreasing order of the powers. That's just a conventional thing. And to conclude our algebra review, we're going to talk about lines. This is actually generally something that people are very comfortable with, but let's just talk about it anyways. Lines, of course, can be drawn. You have points on a line. We're going to generally pick 2 points, x1, y1, x2, y2. We can find the slope of that line by taking the change in the y's, so y2 minus y1, and dividing by the change in the x. That's your rise over run formula. Okay. Now, what we care about is finding equations of lines. So there's 2 forms for equations of lines that you need to be comfortable with. I said 2, but I meant 3. The 3 forms are point-slope form in red, slope-intercept form in blue, and standard form in green. So point-slope form, this is useful when you are given a point on the line and the slope of the line. You can find the equation of the line by inputting that information right into y minus y1 equals m times x minus x1, and you will get a linear equation which represents the slope passing through that point with that slope. Now, the other form is if you are given the y-intercept, which we call b. That's the point where the line crosses the y-axis. So that height is called b. If you're given the y-intercept and the slope, you can input it into the slope-intercept form, y equals mx plus b, and you will get the linear equation representing the line that has slope m passing through the y-axis at the height b. Standard form, this is the one that doesn't really matter much, but generally we like to express our final answers in standard form. I don't really care, guys. If you get the right equation, you get the right equation, whether it's in 1, 2, or 3 form. It does not matter to me. So let's do a few examples on how to use these forms to find the equation of a line. So we'll do it for two lines. Part A, let's find the equation of the line that passes through the points 1, 2, and 2, 4. So right away, we can't just go right to one of our forms, but I generally lean towards using point slope form. I have a point, so I'm going to pick either of these points. I'm just going to pick the first one, nice and simple, 1, 2. Now to find the slope, we're going to use the equation. So think of this as your x1, y1, and this as your x2, y2. So we're going to take the difference of the y's, so that'll be 4 minus 2 over the difference of the x's. So you end up with 2 over 1, so your slope is 2. So I have a point of 1, 2, and a slope of 2, and we're going to go right into y minus y1 is m times x minus x1. So you'll have y minus y1, which is the value 2, is equal to 2 times x minus x1. You can circle that. That is the equation of the line. If you're asked to put it in slope-intercept form, you just need to manipulate it and expand it out so that you get it into the blue form. Or if you're asked for standard form, you do the same thing. Okay? So I'm going to leave this as is. Now for the last one, if we are told that the line has a slope 4, then that's my m value, and it passes through this point, that's x1, y1. We can literally jump right into slope-intercept form and put in all of the information that we have. Be very careful with those minuses because they're going to become positive. So you'll end up with y plus 5 is 4 times x plus 1. Again, be careful of what form it asks you to express it in. So for example, on this last one, if I wanted this in slope-intercept form, I would move the 5 over and I'd distribute the 4 in here. So I'd have 4x plus 4 minus 5. So you end up with 4x minus 1. All right, so you actually would, you would actually have a final answer there of y equals 4x minus 1. That's the same line, and that's in slope-intercept form. So be careful of what they ask for. All right, so that's it, guys, for the algebra review. I hope that this was helpful, and again, make sure to get a good foundation with this before moving on to the calculus concepts. All right, let me know if you need any help.